Here we have some questions that deal with sort of the basic definitions of the main bits and pieces that geometry starts with. So points and lines and planes and other things like that. And we're going to try to get familiar with the definitions just by trying to answer these questions, and we'll just talk about these things as they come up. So let's just start with the first question here. It says, which is a description of a segment? So a segment is part of a line, whereas a line goes on forever. A segment might be part of that. You put a couple of points in there, and then you call that segment AB. If you saw that off by itself without the line there, it would look like that. So that's a line segment. Oops, let me pull that down a little bit. That's a line segment. So let's see which definition fits here. A, an undefined term of geometry. It has no size in any dimension. Now, that's actually the definition of a point. A point doesn't have length, doesn't have width, doesn't have thickness. A line segment has length, so that's size in one dimension. So A doesn't fit. B says it has no thickness or width, and it extends indefinitely in one direction from an endpoint. Well, that would actually be a ray. So you'd have an endpoint, and it would extend indefinitely in one direction. That one would be ray A. But that's not a line segment. Line segment doesn't extend indefinitely. C says all of the points between two endpoints. Now, that's actually the right answer. And it sounds a little funny. It's kind of a funny way to think of a line, but you can think of it that way. A line segment is made up of all these tiny little points all put in a row together. So a line is an infinite number of points all along that one line. A line segment is all the points between the two endpoints. And let's just look at D. An undefined term in geometry, it has no thickness or width but extends indefinitely. Well, that would actually be a line. It has length but no thickness or width, and it goes on indefinitely in both directions. Let's look at the next one. This one says a line, and then they want always, sometimes, or never, contains at least 2 points. Well, as we just talked about, you can think of a line as an infinite number of points all lined up here. So it's always going to contain at least 2 points. The special thing about 2 points is that's how many points it takes to define a line. Anytime you put 2 points down on a plane, you can draw a line between them. Doesn't matter. Any 2 points, you can make a line out of it. All right. Let's look at this next one. It says, which is the best description of skew lines? And I'm going to grab another marker here, and we'll just pretend that these are lines. So imagine they go on indefinitely. And you know that in a plane, lines are going to cross each other at some point unless they're parallel. If they go in exactly the same direction, then they extend forever without ever crossing each other. But there is a way to have lines that aren't parallel but never cross each other. And the way is if you take one of them and move it up onto a different plane. So this line is above the other line, and it doesn't physically intersect with it because there's space in between here, but it's not parallel either. So they never intersect, but they're not parallel. That's what skew lines are. So let's look at this one. Which is the best description of skew lines? A, intersect to form a right angle. Well, no, they don't intersect. B, do not lie within the same plane, yep, and never intersect. That's correct. C, form an acute angle, no. D, lie within the same plane and never intersect. That would be the definition for parallel lines. All right, one last question here. This one says, which of the following statements is false? A, line is one-dimensional. Now, when you think about dimensionality, a line has length. Length, width, thickness, those are dimensions. It has just length. It doesn't have width or thickness. So that is a one-dimensional thing. An example of a two-dimensional thing would be like a square or a plane. And an example of a three-dimensional thing would be something like a cube. Let's look at B here. So anyway, this is true, so that's not what we're looking for. B says rays that are subsets of parallel lines may not be parallel. Now that sounds a little tricky. Let's think about this. Let's say we have two parallel lines. So they're going exactly the same direction. They never cross each other. To make a ray that is a subset of a line, you just put a point there, and then we have ray A that goes from this point A all the way out in this direction. And we could make another ray down here, ray B. Now, if the lines were parallel, the rays are definitely going to be parallel. So this one's actually false because it's saying they may not be parallel. And that's what we're looking for. We're looking for the false one. Let's just make sure that C and D are correct. C says skew lines do not intersect. That's correct. And D, any three non-collinear points determine a plane. And that's true. Just like 2 points is enough to determine a line, 3 points is sort of the minimum requirement you need to determine a plane. So that's a little bit of work with some of these basic terms and definitions.